Connected to ground means that here you can zoom. Connected to ground means that it's measuring high. So now what we can see is that two of the sensors, that is red and blue, are measuring maximum measured parameter because it's connected to ground and it is of the reverse logic, and the left two are measuring the lowest condition. So we can say that two are in 100% condition and the left two are in 0% condition. So if we take an average of all the four, it will be somewhere around 200 divided by 4, so that would be around 50. So the measured parameter over here is now 50, or the measured sensor value is 50, and I have just set the set point at 76. So that makes the error to be error will be then 76 minus 50, that is positive. So obviously if there is error, the system will try to nullify the error. And so in my slave system, what is happening is like one of the relays will go on. Now which relay, that will again depend on which one I have selected. Now I have selected the motor control, as you can see, because these two are shorted. If you can see over here, these two are shorted, right? So it's motor control, right? So this relay, or this relay and this relay, both the relays should be turning on. So since both the relays is turned on, now I can just plug in the light and see. And yes, here you can see that the blue LED has turned on, the blue lamp has turned on, which shows that the system has switched on the pump, right? Now let us do some trick. That is, let us now change the values abruptly. What I will do, these are the two sensors, the green one and the white one, which is sensing a low value of the measured parameter because they are connected to 5 volt. So what I will do, I will just change one of them to ground, which means that the measured parameter is high, so that is 100%. So now we have 3 sensors measuring high condition. This is measuring high condition, this is measuring high condition, the red one, and the blue one is also measuring high condition. See, all of them are grounded, if you can see, right? So that's 300 divided by 4. So now the value is somewhere below 76, but there's a hysteresis loop that I will explain later on. So now if I also connect the 4th sensor to high measured parameter, then what will happen? Immediately you will see that after some time the pump motor should go off, but that will only happen if you receive a valid data. See, the valid data was received and the lamp goes off, which shows that your water level is now fine, so you don't need the pump on or the motor on. Now the same operation should be done with the solenoid valve as well. Now how do we do that? Now for setting to the solenoid valve condition, this particular jumper is responsible. So we need to change the jumper setting to the solenoid valve side. See, I have done that. I have set it to the solenoid valve side. Previously it was connected to this particular pin. Now it is shifted to this. Now what I will do is I will purposefully connect the sensor to 5 volt so that the system assumes that the measured parameter has dropped. And here you see the red lamp is on, which means that the solenoid valve has been turned on, right? So this is how you can see that how the message is being transferred using the long distance communication. And let me be very clear to you, that is what we are using for a long distance communication is a simple UTP, that is unshielded twisted pair cable, that is Cat5e cable, which is used in LAN communications, and this is good enough for an RS485 communication. But if you want, obviously you can use better communication techniques, not an issue, but this is pretty fine. And well, I think that covers most of the topics regarding this particular device. One important feature that I can tell, which is not very important, but it's pretty important, I should let you know, is that you can just random shift the control from the solenoid valve to the pump motor, that is for this one. So if randomly I change the jumper to the motor, see, I changed it to motor control, so there should be a swapping right here. Let us see if that happens. But only if it receives a valid data. Yeah. So here you see that the blue LED goes on, the blue lamp goes on, which shows that the motor has been turned on and the valve has been switched off. Now, one important thing you must realize is that I haven't demonstrated the emergency condition. You can see that there are two LEDs, one is power and the other is run blinking, and there is this valid data which will keep on, it will flash after 17 to 20 seconds. Yeah, as you've seen just now. So this valid data LED will blink whenever it decodes or it fetches a valid data stream from the master. So now if I just plug out the emergency, if I plug out the emergency, it means that my system is under emergency situation, so my motor should be switched off immediately, and that is exactly what is going to happen in the next data stream it receives. Here the LED goes off, the lamp goes off, and you can see the red LED is on. So the red LED basically says that that something is wrong with the master side. There is some kind of emergency condition that is there for which I had to switch off the lamp or the motor. So as soon as the emergency condition goes off, so I close the emergency loop, and here you have the lamp working. So this is the thing. You can find many applications of this particular device. You can also make your own slaves by using LEDs and LCDs and color LCDs, touch screens with Bluetooth, with the mesh communication, Zigbee, Wi-Fi, with even you can control loads at remote locations like this. But one thing that I need to say is that how different it is from the Branon that I have discussed, another product that we have out here. Well, in Branon, it is a programmable load controller. There you can control the speed of a load. You can control the turning on and off directly of the load. Here you cannot do that. You cannot have a switch or a web-based application or a app running on your mobile where you press a button and you can switch on or off the pump motor or the solenoid valves. It only happens according to a control logic that is written inside the device and according to the measured measured values and the given set point. But over there you can have that. You can control the entire device and the loads, and you can reprogram it. Here you cannot reprogram it. It will be very clear. You cannot reprogram it unless and until you change the code. The second feature in this device, which varies from the Branon, is this is a sensor dependent one. Branon doesn't have sensor integration. Here, this particular device will have application in areas like watering, gardening, in hotels where you need to monitor whether your room temperature is fine. Suppose if you have multiple room temperature measurements, you can use many such masters and communicate with slaves. You can use this for water level control in domestic houses, in domestic areas. You can even do it in hotels. You can apply it for pressure monitoring. You can even measure. You can connect ECG sensors and you can measure the ECG values and show it on a website. So there can be a numerous number of applications because of the fact that the sensor area is totally sensor independent. It's up to you how you scale the measured parameter, and you scale it to the 0 to 5 volt range, and and you can see the value in the website. Right, so if you want to see the value in the website, this is the link you got to click to, and for username and password you have to just write into the comment section below, or maybe email me at turjashu@turjashusworld.in, or just visit my website. I will be giving you the link, but it's pretty simple. You can customize yourself, and for more information please do log on to my website www.turjashusworld.in, and I'll be uploading more projects, some good ones coming up very soon. Thank you. Bye bye. And please, if you like this channel, do hit like, and please subscribe to my channel. Thank you.